For number 4, we're looking at the determination of the length of the curve represented by the function y is equal to 2x plus 3 quantity to the 3 halves between x equals 0 and x equals 1. Okay, so we have in the setup, again we have with the function y is equal to 2x plus 3 quantity to the 3 halves as x runs from 0 to 1. And now for the length of the curve, again we're going to need the derivative of the function. And if we put the derivative in terms of dy over dx, okay, now we have, in accordance with the power property of the derivative, okay, now we're going to have 3 halves times the quantity of 2x plus 3, which by then will be raised to the 1/2 degree. And since the derivative of what we have quantified ends up being a value other than 1 itself, we will have to take the chain rule. So we're looking at taking the derivative of 2x plus 3, and that is going to end up going to 2. And as we look at multiplying what we have, we're going to have 2 times 3 halves, which would be 3. And so we can say that for the derivative, we're going to end up with 3 times the quantity of 2x plus 3 to the 1/2, or by then you can just write this as the square root of 2x plus 3. Now, in looking at what we have upon squaring the derivative, now the square of 3 is going to be 9. That of the square root of 2x plus 3 will be 2x plus 3 itself. And so we have for the square of the derivative, okay, we have 18x plus 27. Now, in looking at what we have for the determination of the arc length itself, again we have for the arc length, okay, again we have x is going to run from 0 to 1. And we have of the square root of 1 plus the quantity of 18x plus 27 dx. And we have in the follow through, we have integrating from 0 to 1. If we combine the terms together, now we have the square root of 18x plus 28 . And okay, we'll get back to this particular portion, but now we're looking at taking the integral of the square root of 18x plus 28. So just as relegating back to the integration by substitution. Okay, now we have for the integral of the square root of 18x plus 28. Now, in terms of integration by substitution, again, we can set u equal to 18x plus 28. And taking the differential of both sides, now u becomes du. And as for 18x plus 28, okay, this will become 18 dx. And rewriting what I have in dx in terms of du, we have du over 18 is equal to dx. And so as I look into substitution, okay, now again in place of 18x plus 28 I have u, which will be raised to the 1/2. For dx I have again du over 18. So we're going to have 1/18 of the integral of u to the 1/2 du, and in the follow through we have 1/18, and with the integral of u to the 1/2 we're going to have 2/3 of u to the 3 halves, and 1/18 of 2/3. Okay, in simplified form this will be 1/27. And with the back substitution, okay, for u again we have 18x plus 28, which we raise to the 3 halves. We have followed by the constant. Okay, so taking what I have here, And going back to the length of the curve problem, okay, we have where the length. Okay, now we're going to have 1/27th of the quantity of 18x plus 28 to the 3 halves. So x goes from 0 to 1, and so in the follow through, okay, plugging in 1 for x, okay, we're going to have 1/27th, 46 to the 3 halves, minus 1/27th of 28 to the 3 halves. And this is one form upon which the exact result can be expressed. And if you were to express as a decimal value, okay, you would end up with about 6.07 units.